Hi students, today we are going to see inverse Z transform by partial fraction method. This is Benila from RM Engineering College. Inverse Z transform means the process of finding x of n from its Z transform x of z. There are four methods to find inverse Z transform. Number one, partial fraction method. Number two, long division method. Number three, residue method. And number four, convolution method. So today we are going to see how to find the inverse Z transform using partial fraction method. So steps to find the inverse Z transform using partial fraction method are: step 1, obtain the function in positive powers of z. Step 2, divide by z on both sides. Step 3, factorize the denominator into first order terms. Step number 4, express the equation in partial fraction methods. So always the number of constants we use depends upon the number of terms in the denominator, and find the value of the constants. And step number 5, multiply by z on both sides. Step number 6, obtain the function in negative powers of z. And step number 7, find the values. So for finding the values you can use this tabular form. So if your x of z is of the form 1 divided by 1 minus a z inverse, your x of n will be a power n u of n. If it is 1 divided by 1 minus z inverse, it will be only of u of n. Then z inverse divided by 1 minus a z inverse whole square is n into a power n u of a power n minus 1 u of n, and it's so on. If we apply this 7 steps, we'll be able to find the inverse Z transform for any kind of problem. So let us solve a problem here. So obtain the inverse Z transform of x of z is equal to 1 divided by 1 minus 1.5 z inverse plus 0.5 z power minus 2. For ROC, modulus of z greater than 1. For mod OC, modulus of z less than 0.5. And for 3, modulus of 0.5 less than modulus of z less than 1. So the solution is, so the given function x of z is equal to 1 divided by 1 minus 1.5 z inverse plus 0.5 z power minus 2. So step number 1, obtain the function in positive powers of z. If the function is in already positive powers, we will go for the step 2. But here your x of z is in negative powers. So to get it in the positive powers, take your z power minus 2 commonly out in the denominator. So if I take it, it becomes z square minus 1.5 z plus 0.5. And if I bring that denominator to numerator, it will become z square. Z power minus 2 becomes z square. So now your x of z is in positive powers. Step number 2, divide by z on both sides. So x of z divided by z is equal to z square divided by z into z square minus 1.5 z plus 0.5. So now, so we can cancel this 2 and then the z. So now we'll get z divided by z square minus 1.5 z plus 0.5. So step number 3, factorize the denominator into first order terms. So if I factorize the denominator z square minus 1.5 z plus 0.5, I'll be getting z minus 1 into z minus 0.5. Here, if you want, you can use your calculator to find the factors of the equation. So the steps to follow is, go to your calculator mode to equation. So mode, choose equation, and unknowns. You have to choose unknowns 2. After choosing that one, A, B and C you will get. So type A as 1, B as minus 1.5, C as 0.5 and give equal to. You will get two values. Now x1 is equal to 1, and if you press equal to, you will get the second value. X2 is equal to 0.5. So that tells you that it's 1 and 0.5, z minus 1 and z minus 0.5. So step number 4, express the equation in partial fraction method. So the number of constants that we are going to use is 2, because you have two first order function terms here. So a divided by z minus 1 plus b divided by z minus 0.5. to find the values of the constants a and b. So I'm going to replace this x of z by z as this term. Then I'll be taking the LCM of this one. So z minus 1 into z minus 0.5. So it's cross multiply a into z minus 0.5 plus b into z minus 1. So this term and this term will get cancelled. So I'll get that at net of z is equal to a into z minus 0.5 plus b into z minus 1. So if I substitute z is equal to 0.5, then what happens here? Substitute it in the equation. This z is replaced by 0.5. This entire term becomes 0. 0.5 minus 0.5 will be 0. Here b into 0.5 minus 1, it becomes minus 0.5. So the b value is 1. So if I substitute z is equal to 1, so 1 is equal to a into 1 minus 0.5 is 0.5. This term will become 0. So a equal to 2. So now I can replace a and b in this one. So the obtained function is x of z divided by z is equal to 2 divided by z minus 1 minus b is equal to minus 1. So minus 1 divided by z minus 0.5. Step number 5. Multiply by z on both sides. So if I multiply by z on both sides, so this z and z it will cancel. So here it will be 2z divided by z minus 1 minus 1z divided by z minus 0.5. So step number 6 is obtain the function in negative powers of z. So I'll be taking z commonly out in the denominator. If I take z out, it becomes 1 minus z inverse. This z and z get cancels. Here this z commonly out. So 1 minus 0.5 z inverse. So z and z cancels. Finally the term will be of negative powers. Now I'll be finding the values x of n using the tabular form. So it is of so here this is your 2 divided by 1 minus z inverse. So your a value is 1. So it is 1 power n u of n. So it is 2 u of n. And here it is 1 divided by 1 minus 0.5 z inverse. So 0.5 power n into u of n. So your x of n that obtained is x of n is equal to 2 into u of n minus 0.5 n into u of n. So in the problem they ask you to find the x of n for 3 different ROCs. Normally the poles of this equation will be 1 as well as 0.5. So there are 2 poles. So all the 3 will be of this within this 2 combinations. The 3 combinations will be with the help of these 2 poles. The first combination is modulus of z greater than 1. If your modulus of z is greater than, then we can say the system is said to be causal. If it is less than, it is said to be non-causal. So if it is a causal, then there is no issue. Whatever the x of n you have obtained will be the same. For the second one, modulus of z is less than 0.5. So since it is less than, the system is said to be non-causal. For non-causal, 2 corrections you have to do in the x of n that you have obtained. One is the coefficient sign change. Number 2 is u of n should be replaced by u of minus n minus 1. So what happens? X of n is equal to this plus 2 becomes minus 2. U of n becomes u of minus n minus 1. Again this minus 0.5 power n becomes plus 0.5 power n. U of n becomes u of minus n minus 1. So this is the x of n for this non-causal system. Number 3 is 0.5 less than modulus of z less than 1. Here this modulus of z less than 1, this becomes non-causal, right? And then here this 0.5 less than modulus of z, this becomes causal, because I can write this as modulus of z greater than 0.5. So this becomes causal here. So if the pole modulus of z greater than 0.5 is going to be causal and less than 1 is going to be non-causal. So for a pole less than 1 is non-causal. So your x of n is equal to here the pole is 1, so it is non-causal, so minus 2 u of minus n minus 1. Here 0.5, for the 0.5 it is going to be causal, so it is same as that of the equation given. minus 0.5 power n u of n. So which pole is going to be causal? There will not be any change. For the pole which is going to be non-causal, then only you have to do the two corrections, that is coefficient sign change and u of n to u of minus n minus 1. So that's it for today. So thank you guys, and subscribe my channel for automatic updates in signals and systems and TSP. Have a nice day.